Today I'm going to do a problem using linked list. The problem says that we have an unsorted linked list and we want to remove the duplicates. So let's say that our unsorted linked list looks like the following: 10, 5, 2, 5, and at the end 8. Okay, and this 8 is going to be attached to a null to say that okay, we have reached the end of the linked list. The first solution that we can have for this problem uses a temporary buffer. Let's say our temporary buffer is called visited. Okay, so what this visited does is to say, okay, if we have visited a node, we know that if we visit it again, that's going to be a duplicate. So that way we can keep track of the things that we have visited and avoid visiting them again. Now, the algorithm that we have for solving this problem is as follows. So the first step, actually the 0th step, is to initialize your variables. So let's say we have a variable called current, and we set this variable current to be the head of the linked list. And then we have a variable previous, which we're going to set it to null. The first step of our algorithm is going to be to check if the current variable is equal to null. So if the current is equal to null, means we have reached the end of the linked list. So if the current variable is equal to null, return the linked list. Okay, return the result that you have found. Otherwise, go to step 2. So if you return, then we're not gonna execute any of these steps. So that's safe to say. That's safe to not say else. Okay. So if current is equal to null, we know that we have reached the end of the linked list and want to return the result that we have found so far. Else, we're gonna go to the second step and say if current is not in the visited list, do these 2 steps. First, put current in visited. So put current in visited. Second, say that previous is equal to current. Okay, so move previous to a new location, which is the new location is current. Okay, else, which means if the current is in the visited, you're gonna also do another task. So if the current is in visited, you're gonna say previous.next is equal to current.next. And in both of these situations, either you have the currents in the visited buffer or you don't. You want to increment current. You want to move current to the next node. So current is equal to current dot next. And then the 5th step is to go back to step 1. Okay, now let's see if our algorithm makes sense or not. For ease of use, I'm gonna say that current is just C and previous is P. Okay, so current is pointing at the head and then previous is pointing at a null. Actual previous is a null. Now the first step says if current is equal to null, return the linked list. So let's check the current. Current is not equal to null. Current is equal to the head of the linked list here, and it's just 10. So we're gonna skip this step. We're gonna go to step 2. If current is not in visited, so let's see, current is 10, the node 10 here is not in the visited. So I'm gonna execute these 2 steps. I'm gonna put current in the visited buffer. So now I'm gonna put 10 in here. Okay, so I put it in the visited buffer, and then I'm gonna say previous is equal to current. So I'm gonna get rid of this null here, and I'm gonna point this previous to this current position. So current is looking at the head of the linked list, so previous is gonna look at the same position as current is looking at right now. Okay, now so else is not gonna be executed because we have executed if. We're gonna go to the next step, which is step 4, and we're gonna say that current is equal to current.next. So current.next is gonna be 5, so current is gonna be now current.next. So current is gonna look at this guy. Now step 5 says go back to step 1. We go to step 1, current is not equal to null. We're gonna go to step 2, current is not in the visited, so let's see, 5 is not in our visited buffer, so we're gonna execute these two steps. It says put current in the visited buffer, so we're gonna put 5 into here, and then we're gonna say that previous is equal to current, so previous is gonna move in here. Okay, now the next step is to say current is equal to current.next. So we're gonna move this current to the next position and then go back to step 1. Step 1 is if current is equal to null. It's not equal to null. We go to the next step, is not in the visited buffer, so we're gonna put the current in visited buffer, so 2 is gonna also go here, and then previous is gonna go to the position of current, and then else is not going to be executed, and then we're going to go to step 4, which says current is equal to current next, so we're going to move this current in here and then go back to step 1. So step 1 again says that have we reached the end of the linked list? It says no, so we're going to execute step 2, which says if current is not in visited. But here the visited the visited list includes 5 in it, right? So we have 5 and the current is 5. So we're gonna execute this else statement. So else is telling us that we have to put the previous.next, okay, so this guy, to current.next. So previous.next is gonna be pointing at current.next. So it's gonna point at here. Okay, now what it does is to deattaches the rest of the linked list from this node, from this node 5, which has occurred before. So we're getting rid of the duplicate. Now the next step is saying that current is equal to current.next. So current.next is going to be 8, and then we look at it, and then we're gonna go back to step 1. If we go to step 1, so again, before I continue, remember that I didn't do anything with P anymore. Okay, I didn't move it to any other places. P stays at the same position, but it's gonna look at the next of our current node, and then we move our current node. We go back to step 1. Step 1 is not true, so we're going to step 2. Current is not in the visited buffer, so we're gonna put 8 in here, and then we're gonna set the previous to be at the position of current. So our previous is gonna move now here, and then we're gonna say current is equal to current next. So current now is gonna look at this null. So current now is equal to null, because we have hit this part, and then it says that go back to step 1. Step 1 is saying that if the current is equal to null. In this case, the current is equal to null, so you're gonna return the linked list that you have made so far. So what you have made so far is 10, 5, then 2, and this 2 is looking at 8. Okay, so 2 is looking at 8, and then 8 is looking at null. And that's the linked list without any duplicates.